Now we're ready to do 5.8 Part 2. And our learning target is kind of long here. Has a lot of words to it. But I need to put all those words in there, I believe. Okay, so we're going to determine the turning points. Local maximum or local minimum and x-intercepts of a graph of a polynomial function. These are just important points on our graph of a polynomial, and we haven't talked about them yet. Let me draw you a picture of a polynomial. This is actually a cubed graph, but it would be true on an even or to the fourth power graph as well. So the turning points show you where the graph changes direction. And if we marked this point right here, it's not the highest point because this goes on and on forever, but we call it a local maximum. And this point right here, it again is not the lowest point since this keeps going down, but we call it a local minimum. Now your turning points, where the graph changes direction, occurs at these local maximum and minimum points. So the turning points correspond
We need art club and science club members. Please go to the gym for pictures.
to the
Art
local
club and science club. Please go to the
maximum
gym. Thank you.
and minimums and they show where the graph changes direction. Okay, so let's look at an example of what you're going to have to do with this. So the problem will ask you to estimate the coordinates of each turning point and state whether it is a local maximum or minimum. And I'm just going to write local max or min. estimate all real zeros and determine the least degree the function can have. Alright, so to do this, you're going to have a picture of a graph. So let's draw in a picture of a graph here. Alright, so this is going to be an even positive graph. And we need to put a point right here too. Okay, so the first thing it says is estimate the turning points, the coordinates of the turning points. So I'm going to put another point right here. So this would be one turning point where it changes direction. Here would be another one, and here would be another one. So let's do the turning points. Okay, we're going to estimate the first turning point to be negative 0.5, negative 1. I'm just naming that point right there. And that would be a local minimum since it's a low point there. On the second one, I'm going to estimate it to be 1.5.
We need all FCCLA members,
And I forgot to mark
History
that.
Bowl members, and Academic Bowl members to please report to the gym for pictures. All FCCLA, History Bowl, and Academic Club members, please report to the gym for pictures. Thank you.
Okay, so I'm estimating that to be about 1.5 and 1. And that one is high, so it'll be a local max. Or a local maximum. Okay, then let's estimate this point to be 4, negative 5. And again, that's a low point, so it'll be a local min. Okay, now we're going to estimate all the zeros. Remember that these are the same as the x-intercepts, okay? So we have 1, 2, 3, 4 x-intercepts. So the first one right here, that would be negative 1, 0. And then right here, we would have 0, 0. And then we would have 2, 0. And the last one would be 5, 0. Okay, now we have to do the least degree that the function can have, the smallest degree. We know we said it was even, and it's definitely not a parabola, but it's opening up, so the least degree, the smallest degree that it could possibly have would be 4, because we know it's even and we know it's not cubed. So the smallest one would be 4. All right. that concludes this video.